Dear students, very good morning. This is your Professor Subramanya Bhagavat, Computer Science Coordinator. Welcome back to Discrete Mathematical Structure, where we were studying fifth model, Introduction to Graph Theory. Last class I have clearly told you about what is a graph, what it contains. Graph is nothing but a group of non-empty set of vertices and edges. Then examples we have studied. Yeah. Now this class, last class these examples we studied. This class we will continue. I was explaining you about order and size. What is an order? Number of vertices in a graph is known as order of the graph. Order of the graph is nothing but the number of vertices in a graph. How many vertices are there? That is nothing but an order of a graph. Where the number of edges in a graph, number of edges in a graph is nothing but a size of a graph. Okay, size of a graph. A graph of order n size and m is called nm graph. If you observe this, okay, wait for 2 seconds. 2 seconds I'll give you. Just think about that. What is the order of this graph and size of this graph? Try to identify and tell me. I'll give you 2 minutes. 2 seconds. Can you tell me that one first graph? What is the order and what is the size? Observe this very clearly. First graph, okay? A, B, C, P, Q, R. Am I right? Yeah. A, B, C, P, Q, R. How many vertices are there? 6 vertices. How many edges are there? Just edges. Observe this. A to P, 1 edge. Wait. Yeah. A to B, this is 1 edge. Then B to Q, this is 1 edge. Second 2, this PQ, P to C 3, Q to C 4, C to R 5. So 5 edges. And the order is what? Order is how many vertices? 1, 2, 3, 4, 5, 6. 6 vertices. Order is 6. 5 these things, what I call edges. So size is 5. This graph is nothing but 6 vertices, 5 edges, order is 6, size is 5. Then come to this graph, okay. How many vertices are there? P, Q, R, S, T. 5 vertices are there. Then how many edges are there? P to S, 1 edge. P to Q, other edge. Q to R, other edge. Then R to T, this edge. S to T, Q to S, Q to T, and S to T. So 1, 2, 3, 4, 5, 6, 7 edges are there. This graph 7 edges. Payu, PQRST, Payu vertices. So the order is Payu and 7 edges size is 7. Now we understood, wait, yeah. We have understood order and size. Next one, wait. Yeah, directed graph. What is a directed graph? How do you define a directed graph? Any graph, graph is nothing but a group of non-empty vertices and edges. Observe the speciality of edges. If the edges, wait, if the edges, graph is nothing but group of vertices and edges. Where these edges, if the direction is mentioned, for example, this is A, this is B, direction is mentioned, edge should be A to B, you should not write BA. So directed graph is nothing but, wait, directed graph is group of what? Group of non-empty set of vertices and directed edges. And the edges directed, okay, that is called, okay, directed graph. Example is this. If you observe this, you see here, if you compare the graph and this graph, there's a speciality. Edges, direction is mentioned. Edges direction is mentioned like A to B. This edge is A to B. You cannot write, wait, this edge is A to B. Yes, clearly given. While writing edge set, I should write AB. This direction is mentioned. Suppose if you write BA, wrong it is, because B to A edge is not there in directed graph. Directed graph is graph group of vertices and edges. Okay, Wow, very clearly you have to observe edges should be directed edges or direction is mandatory. Next one, yeah, this one. Now, if you observe this, okay, in degree and out degree, that is what is that in degree directed drafts? Okay, very important thing. In degree is nothing but number of vertices entering. That is called in degree. If you observe the V1, how many vertices are entering? Carefully observe this. How many entering? Entering is 0. There's in degree is 0. Where out degree, how many are going from V1 edges? 1, this is 2, this is 3, yeah, this is 4. So 4. So out degree is 4. Observe this. Vertex V1's out degree is 4, in degree is 0. What about V2? V2, where is V2? Yeah, here V2 is the weight. In this V2, okay, wait for a second. Just think about that, okay? What is the in degree, out degree? In degree, out degree is clear to you, right? In degree is nothing but number of edges incoming. Out degree is nothing but number of edges outgoing from that vertex. If you observe the V2, okay, observe that V2 is here, okay, wait. V2, what is the in degree? In degree V2, if you observe V2, in degree is nothing but how many number of vertices are coming to V2? Only one edges is coming to V2. Sorry, in V2, how many not vertices, how many edges are coming? How many, observe this, in degree is nothing but how many edges are coming to that vertex. Here, how many edges are coming to vertex V2? Only one edge is coming to the vertex V2. In degree is 1. Am I right? V2's in degree is 1. Exactly right. What is the out degree? Out degree is nothing but how many edges are going from V2. How many edges are going from V2? This is going, outgoing. This is going. Two edges are going from V2. Out degree is 2. Out degree is 2. Yeah, exactly right. Now please observe that very carefully. Now, wait. Now please concentrate. V3. What about V3? What about V3? How many what is the in degree of V3 and out degree of V3? Carefully listen. In degree is nothing but how many edges are incoming. For V3, how many edges are in going this edge? One edge is going to V3. This one edge is going to V3. So in degree of V3 is 2. Well, what is the out degree of V3? How many edges are going from V3? This one edge is going from V3. This one edge is going from V3. So out degree of V3 is 2. So in degree is also 2. Out degree is also 2 considered to V3. Then what about, wait. What about V4? What about, yeah, what about V4? How many in degree and how many 1 degree, out degree? Can you say how many in degree and how many out degree? V4. V4 is here. How many in degree means how many edges, yeah. How many edges coming to V4? Yeah. Two edges are coming to V4. This is one edge and this is one edge. So in degree of V4 is 2. How many edges going from V4? How many edges? Only one edge. So out degree is 1. V4's out degree is 1. You can verify this. Yeah, V4's out degree is 1 and in degree is 2. What about, okay, V5? Wait. Cool way you have to solve this. Okay, very cool way. V5. What is the in degree of V5? What is the in degree of V5 and out degree of V5? In degree means how many elements entering into V5. How many elements entering into V5? If you observe this, yeah, only one edge, wait. Only one edge is entering into V5. So I call it as in degrees of V5 is only 1. Where out degree, how many edges going from V5? this one, two, only two, no, carefully listen. From V5, the total three. Three edges going outside. So, out degree of V5 is 3. What about V6? What about V6? Wait. What about V6 now? V6, how many? In degree? In degree is, okay, 2 because 2 are entering. Wait. 2 are entering. Wait. The subject is very interesting. Two edges are entering into V6. So in degree of V6 is 2. Out degree, no edge is going from these things. So V6, out degree is 0. Then, wait. What about V7? What about V7? Where is V7? This is V7. What about this V7? What is the in degree of V7? How many entering? 1, 2, 3, 4. So in degree is 4. What is the out degree? Out degree is 0. No edge is going from that. Next is, yeah, null graph. Graph which contains no edges. Null graph. If I write one point, wait. Yeah, this is A, this is null graph. If I write 240, this is a B, this is a 3, C, B, C. Null graph. This is which given is null graph. Graph with vertices, because graph definition says graph with non-empty set of vertices, edges may be 0, that time null graph. Next is connected graph. Connected graph is last class I had told you very clearly. This connected graph is it doesn't contain at least 2 connected vertices. I clearly explained to you last class. The last class videos go through these things and vertex. Up to here we studied. Now what is a complete graph? Everybody can guess 2 minutes, I'll give you time. Graph is a simple graph, means it doesn't contain any loops or what I call parallel edges, and there is an edge between every pair of vertices. If there is an edge between every pair of vertices, then it is called complete graph. That graph is complete. Main very important thing, graph should be simple graph because no loop should be there, and okay, no parallel edges should be there. Okay, next, there is a edge between every pair of vertices, means from if you observe this, okay, these are all the examples of complete graph. The main thing is name should be written. This is A, this is B. First graph, if you observe A, B, two vertices are A there. First condition, there is no edge, no loop, and no parallel edges, and there's a connection between that vertices, all vertices. A to B, there is an edge. No doubt, it is a complete graph. Okay. Next, this is a complete graph. Okay, complete graph. Next, this graph. This graph, how many vertices are there? 3 vertices are there. How many means all vertices connected? Yeah. A to if you see A to B edge is there, A to C edge is there. If you say B to A edge is there, and B to C edge is there. If you take C to A edge is there, C to B edge is there. Means there is a what I call connection from one vertex to all vertices. So this is a complete graph. No parallel edges, no loop. So it's complete graph. If you observe this, is it complete graph? A, B, C, D. Carefully watch this and come to conclusion. Wait. This is a D. Wait for 1 second. Yeah. Carefully observe this. Yeah, this. Yeah. How many? Yeah. If you observe this, A to D, there is an edge is there. A to B edge is there. A to C edge is there. If you take B to A edge is there. B to D edge is there. B to C edge is there. C to A edge is there. C to D edge is there. C to B edge is there. If you take D to A edge is there. D to B edge is there. D to C edge is there. So this graph, okay, contains, okay, what I call, this graph, okay, there's a connection from one vertex to all other vertices and no loops, no edges, no doubt complete graph. What about last graph? This also, A to this, if you say A, this A, B, C, D, E, okay. A to B edge is the, A to C edge is the, A to C edge is the, A to D edge is the, A to E edge is the, like the B to C, B to A, B to D, B to E. So in a graph, one vertex to all other vertices direct edge is the and there is no loop and no parallel edges, that is called complete graph. Next, which of the following are complete graph? Let us observe from first. Take 2 seconds time, verify it. Is it complete graph? Verify it fast. First one, if you observe first graph, this is parallel edges. What is the definitions of complete graph? They should not contain a loop or parallel edges because this is simple graph. So this is not first two graphs are no doubt. I cannot say this is not a complete graph because here first graph here parallel edge is the second graph loop is the next one. Wait. Okay. If you observe this, wait. Is it a complete graph? Check it. Yeah. If you observe that, this is also not complete graph because complete graph says there should be a line, there should be a edge from one vertex to other vertex. If you all vertexes, they should means connected, means direct connection from. If I take this A, B, C, D, E. Okay. What is the definitions of complete graph? Complete graph says one vertex to other all vertexes there should be a direct edge. A to B direct edge is there. A to C direct edge is there. What about A to D? Edge is missing. So this is not a complete graph. There is no edge between A to D. Means complete graph means there should be a connection from one vertex to all other vertices in a graph. Wait. Next. Yeah. Last one, it is a complete graph? No, because there is no edge from this vertex to this one. So no one is here, complete graph. Next, vertex degree. What is vertex degree? Just now I told in directed graphs. Vertex degree means there in degree and out degree I told. Here vertex degree means direct, not direct graph, just graph. Vertex degree calculation is very simple. Don't make a confusion between, don't be confused like direct graph and graph. If direction is the direct graph, otherwise simple graph. In a simple graph, vertex degree is nothing but there is number of edges joining to that vertices. How many edges are joining to that vertices? But remember, loop is the counted twice. That's called vertex degree. Okay. Can you calculate the vertex degree? I'll give you 2 seconds time. Calculate the vertex degree and write it on a paper, and later we can verify it. Time counts. Yes, all of you have taken. All of you have taken. Okay. Just okay. Take the graph and calculate it. Calculate the vertex degree. Okay. Calculate the vertex degree. What is the vertex degree? What is the degree of V1? Can calculate the degree of V1? Yes. What do you got? Means how many number of edges associated with the V1? How many edges? 1, 2, 3. Degree of V1 is 3. Am I right? Yeah, degree of V1 is 3. Then degree of V2, wait. What is degree of V2? Wait. Wait for a second. Yeah. Degree of V2. V2, how many edges? 1, wait. 1, 2, 3, 4. Degree of V2 should be 4. Am I right? Yeah. Degree of V3, yeah. 1, wait. Degree of V3, simple it is. 1, 2, sorry, degree of V4 I am telling. 1, 2, 3. So it should be 3. Yeah, degree of V4 is 3. Am I right? What is degree of V2? So degree of V3? Degree of V3 is considered 1 edge, 2 edge. When loop is the counted twice, degree is counted twice. So 1 plus 1 plus 2 is 4 because loop is the counted twice. So degree of V3 is 4. Am I correct? So degree is simple. How many edges associated with that vertex? Okay, and how many number of edges associated with the vertex, and loop is the counted as twice. Bipartite graph. Next heading is bipartite graph. What is a bipartite graph? Suppose a simple graph G such that its next heading is bipartite graph you are studying. Suppose a simple graph G is such that its vertex set V is the union of two mutual disjoint non-empty sets V1, V2, which are such that each edge G joins in a vertex V1, V2. Bipartite graph. In other words, general definitions through I tell you. A graph I am able to make a two parts. Okay, one part some set of vertices, second part some set of vertices, and there is a edge between this set to this set, and there is no edges between from intermediate this inside sets. That is called bipartite graph. Example through I explain you, so that concept will be very clear to you. If you observe this graph, I am able to classify the vertex sets like V1 contains A, B, C. Okay. Then V2 contains okay P, Q, R, S. P, Q, R, S. Wait, I'll write it here. V2 vertex set contains P, Q, R, S. Okay. Now these three sets I'll make it one vertex set. These three sets I make it as one another vertex sets. From this V1 to V2 edge is the C, A to P edge is the A to Q edge is the A to R edge is the B to R is the C to Q is the C to R is the. So each vertex sets. Wait for a second. Wait for a second. Each vertex sets, this vertex sets 1 and this vertex set V2. There is a edge between, okay, from this set to this set, and there is no, okay, what I call, there is no intermediate edges, like if A to B edge is not there, B to C edge is not there, or A to C edge is not there. P to Q edge is not there, Q to R is there, R is S edge is not there, P to S edge is not there. This is called bipartite graph. Given graph, I can make a two partition. If a given graph, if I am able to make a two partitions, one vertex set, another vertex set, one vertex set A, B, C, other vertex sets P, Q, R, S. If I am able to make these two vertex sets, and there is an edge between this set to this set, A to P edge is there you see, and A to Q edge is there, okay, like this you can see, okay, that, and there is no intermediate edges between that same part, so that is called bipartite, means I am making two partitions, okay, means in other words, given a graph, if I am able to make a two parts, one part contains some vertices, other parts contain some vertices. Edges from this vertex to that one part to other part, and intermediate part there is no edge. That is called bipartite graph. Complete bipartite graph is different. This is not complete bipartite graph. This is bipartite graph because given graph I am able to classify into two parts. One part contains this vertex A, B, C. Other part contains these vertices P, Q, R, S. P, Q, R, S. There is an edge between okay A to okay P and A to Q. Okay, means this part to this part there is an edge, and intermediate there is part there is no edge. That is called intermediate part means inside that part. So this is called bipartite graph. What is complete bipartite graph? Complete bipartite graph I will explain you in next class. Wish you all the very best.